Well, that was a quick minute, but we'll get started now. This is Rod Stellmuller, another Tech Talk Tuesday. Excited to bring you a really good talk today. We're doing some predictions for 2021 with our team of experts. And so during the presentation, please feel free to ask any questions through the Q&A panel. So with that, let's go ahead and bring up everyone's video and we'll get started.
All right, welcome everybody. Happy New Year 2021. We got together and talked about some of the predictions that we see are going to be happening over 2021. But before we go into that and with some of the experts that we have here, let's look at what happened a little bit in 2020, right? There was a major move to the cloud. Now, we had predicted that. We've been talking about a major move to the cloud for some time now, seeing that enterprise move to that architectural way of doing things. But because of COVID, we actually saw a very significant increase in enterprises moving to the cloud. And that drove actually a lot of thinking within the enterprises. I think they had been, working in the cloud, trying things in the cloud, but as they actually had to do it and they had to operationalize it, that changed a lot of their thinking. So one big thing that happened is that multi-cloud became something that people are doing, not something that they're thinking about. And that was driven by a number of different factors. The basic factor is that some workloads work better in one cloud than they do in the other. So having the ability to have the optionality to run applications in different clouds was a big driver. But we also saw drivers from customers actually asking our customers to be in different clouds because for whatever reason that they didn't want to be in one cloud, they wanted to be in another cloud. And then the second reason that we saw that was really big is mergers and acquisitions. So as consolidation is happening and companies that are delivering their services via the cloud acquire new companies, acquire those technologies, those services may be being delivered out of another cloud. And so to move quickly, they needed the ability to go to multi-cloud. So we saw all of those as factors of why enterprises were moving. Now, the other big thing that we saw was that operations became key. Now, when you're doing cloud at small scale and having the ability to spin up a test environment here or one application here, maybe the operations isn't as complex as it might be once you actually make the major move to the cloud. And so we see our large enterprise customers making operations and automation and trying to simplify all of that, having the ability to get the visibility that they need, to be able to go multi-cloud and see what's going on, to be able to troubleshoot things quickly and reduce the mean time to resolution of any problem that comes up. This became key to why our customers were choosing Aviatrix and why they were putting an Aviatrix transit network in place. I think that one of the other big things that we saw was that the teams that are doing this now, a lot of them come from the on-prem teams and they're moving into the cloud world. And there's a merger of thought processes with the DevOps teams and the on-premise type of operations and way of thinking about architecture has really changed. I think a lot of people wanted to stay the way they were comfortable as they moved into the cloud, but that changed because the simplicity and automation that's available in the cloud really is attractive and people want to take advantage of that. But enterprises needed that enterprise class operations and security. And so the thinking had to change, the way they actually did things had to change. And so we're going to talk about a few of the predictions. I'm not going to give any spoilers. We'll go through and we'll make our predictions along the way. But I think let's go ahead and turn it over. Nicholas, I think you're going to make the first prediction. Is that right?
Yeah, that's right,
All
Rod.
right.
Thank you. So the first is all going to be about containers and Kubernetes. What we see is as enterprises expand their presence in the public cloud, well, in addition to the traditional VM-based workloads, they are also deploying microservices architectures based on containers. And that's typically achieved with Kubernetes, which is a portable, extensible open source platform for managing containerized workloads and services, which is very easy to use. And it has a large, rapidly growing ecosystem. So what we saw in 2020 is an increase in deploying microservices that run on the Kubernetes platform. And we predict that this increase is going to keep being here more in 2021. Now, with enterprises moving to the public cloud, there's a need to support those microservices in the cloud. And what we see is most of the cloud deployments of Kubernetes are actually using the managed Kubernetes services from the cloud providers. We're talking about AWS EKS, Azure EKS, and GCP JKE. And I would say that, especially in GCP, most of our GCP customers are using JKE. Now, the question is, how should an enterprise be prepared for that? The thing is, applications running in a Kubernetes cluster are usually not working in an isolation inside the cluster. There's a variety of traffic patterns that actually happen. For example, east-west, right? You have traffic from your cluster to other Kubernetes clusters running across different VPCs and VNets. And it could be in the same region, or it could be in different regions. It could also be in different clouds. You also have north-south applications that you have on-prem, such as databases that need to interact with your Kubernetes workloads in your cluster, or third-party services that, for example, could be reached via AWS Private Link. Your containers typically also need to egress to the internet. For example, they need to access public services such as API endpoints of Salesforce or other Kubernetes clusters that have a publicly available API endpoint. So the bottom line is, once the application needs to get out of the local Kubernetes cluster and are crossing the boundaries of the VPC or the VNet, then all the advanced networking, security, availability, and operational capabilities, they are becoming a requirement. And yes, the service mesh is one part of it, but it's not enough. Basically, enterprises need to think in advance about their network and security architecture, which needs to support Kubernetes deployments across all those different traffic patterns. The second topic I wanted to cover around application is serverless. Okay, serverless computing is the cloud computing execution model in which the cloud provider is running the server and is dynamically managing the allocation of the machine resources. Typical example are AWS Lambda, Azure Functions, and GCP Cloud Functions. It's efficient and simple because the cloud provider is going to manage the allocation of the resources for you, and all basically you need to provide is your code and what triggers your code. And so we saw a nice adoption of serverless for those reasons, and also because it's cost effective, meaning that the pricing is only based on the actual amount of resources that you consume. And it's pretty cheap. For example, Lambda is 20 cents for 1 million requests. So serverless is already popular, but we really believe that we will keep seeing an increase in this adoption because of those benefits. Now, how should enterprises be prepared for that? Just like Kubernetes workloads, you have your serverless workloads that are typically not working in a little isolated world. They need to access services that are in a VPC in the same cloud, in the same region, or the same cloud in a different region, or even in a completely different cloud, and finally on-prem. And it needs to be in a way that is simple, scalable, secure, and with a deep visibility. One example is it's a common best practice security measure to distinguish between the legitimate and illegitimate outbound internet traffic from your serverless code. And you'll achieve that with FQDN egress filtering service, where you dynamically whitelist and blacklist the destination based on domain names. Now, the thing is, most customers, they are not 100% serverless. And they're not either 100% containers. It's always usually a mix of those environments, as well as, of course, VM-based workloads. So not only you're looking for a network and security platform that provides this type of functionalities um, for containers, for serverless, but in a way that is completely convergent, seamlessly working across all type of workloads and all type of clouds.
Right, that's awesome, Nicholas. So Kubernetes, containers, serverless, all of that needs to connect to the network, and you need all of this enterprise class security, all the visibility that goes with it. So prediction number one there. Now, we see a lot of these applications. Everything is kind of application driven. And I think, Saad, we're starting to see more sort of latency sensitive applications as 5G rolls out and so forth. I think that's kind of the area you're going to talk about, right?
That is correct, Rod. So in 2021, we'll see significant adoption of 5G, IoT, and edge computing type of services. And let me give you some examples of those use cases. My first example is about the online video game companies. Like what they wanted to do, they wanted to provide a smooth experience to their end users. Who their end users are? They are the video gamers. And what they do, they just press the button and they expect to see the results right away. They are could be in any cloud. They could be like connected to any of the 5G or anywhere, right? So basically, their expectation is to see the response right away. And the game developers are facing a lot of challenges over there because what's happening over there, they are trying to fulfill the requirements which are posed by the latency of the infrastructure. So 5G is going to remove all those limitations and open up a lot of doors for these developers. And then the end users, which are the gamers, are going to be happy at that point, right? My second example around the same 5G is the sports fans. What these sports fans do, they want to go to the stadium and watch the games online, right? Like they watch the game live, basically. So what happens, like because of the COVID, they cannot do this thing. When they cannot do this thing, that is, and they are trying to find an alternative. So these are virtual reality-based companies. What they are doing, they are taking the feed into their environment, provide the 3D video, and then transmitting it back to the user, their basically their subscribers. Now their subscribers are watching the game using their headsets, VR headsets, and enjoying the game pretty much the same way as they are enjoying watching in the stadium. But only one text from their family or friends is going to ruin everything if they are getting these feeds with some latency in there, maybe 30 seconds, a minute, or something like that. So 5G again is going to help in there. 5G is already helping with these type of use cases, even though the COVID enabled this use case, but actually it's not going to go away because this is a cheaper way of watching the games, like having the experience like you're watching the game in the stadium. My other example is about the video production, where we're talking about the packaging, the analytics, the distribution. We have to, haul heavy network equipment to on-site, connect them together, and then be on-site and providing the experience, like, and start the video production. So that takes a lot of time and also money. 5G again is going to be really massive over there. And we are seeing a lot of adoption in 2021 in that use case as well. Connected cars and self-driven cars is also very extremely critical use case. I don't know how many times this happened to you guys, but it already happened to me a few times when I'm coming out of some kind of event or maybe from a big mall and I totally forgot where I parked my car. What is the first thing I do? I take out the key fob and then hit the panic button. I'm lucky if I have parked my car somewhere close by. If I have not, then I'm totally out of luck at that point, right? So what these technologies is going to do, all I have to do is to just take out my cell phone and view the live 3D view of my car, exactly where my car is parked. And not only that, like let's say if this is a nighttime, then I can turn on the lights in real time. This is really cool. Related to the same use case which I was talking about, Rod, then there is another thing which is related to the rental car companies. The rental car companies, when we are going to return the cars, our cars are going to go through a 3D or 360-degree basically scan. Those scans are going to be uploaded to the cloud. And then by the time we get to the kiosk, those images are going to be downloaded to the handheld devices. So now, and the person who is going to check us out, he has the complete knowledge whether there are any new dings on the car, whether there will be the car has been into any kind of accident or not. So a lot of cool stuff is coming. So far, I mean, I talked about everything related to the 5G, right? What about those edge computing services use cases? So let me give you a few more examples on those as well. So I'm going to give you example of hospitals and some manufacturing plants where they transfer terabytes, if not petabytes of data, because these scans like CT scans and then the MRI, those are huge files. They are transferring these files. If they are going to transfer these files, continue to transfer these files over to their normal regions, which are their home regions, that is going to add a lot of latency. And these applications are very latency sensitive. So what they are going to do, they are going to deploy those AWS Outpost, Azure Stack, and all those kind of rack-based services in their data center. But again, when they deploy this thing, that is going to pose some more challenges. Why? Because nobody wants to deploy a single application in those racks, right? The different departments, they are saying, okay, I mean, we do have more applications which are latency sensitive, and what we want to do exactly the same thing. So in Outpost, in Azure Stack, you are talking about creating a same transit network, trying to provide the connectivity between each other. You have to make sure everything is protected, secure, firewall, service insertion, all those kind of things are going to exist in there as well. So basically, the point I'm trying to make, doesn't matter whether customer is going to adopt the edge zone, waveland, mobile edge cloud, or Outpost or Azure Stack, anything. The architecture is going to play a very, very critical and big role in there. Why am I saying it? Because let me give you an example, right? If you are online video gaming company, you're not going to settle down with only one type of users, like just the AT&T. You want to gain the business of Verizon, Vodafone, T-Mobile, all different types of carrier service provider. So what basically we are saying we have to find a way to connect all these 5G services together. And not only that, the application of these companies will be sitting in multi-cloud environment. So basically, we are talking about adding more and more challenges. When we are adding more challenges, basically, we are adding more and more complexity. So did I answer your question, Rod?
Yeah, no, that's a great prediction. So, we're seeing 5G, edge, all of that drive, really driven by the applications, to your point, right? So the applications need to get closer to the users, need to get closer to the compute. And so that's prediction number 2, right?
Yep. But was thinking that, we are talking about applications, 5G, IoT use cases. Don't you guys think it will increase the operational overhead and the overall complexity when it comes to managing these infrastructures? What do you think?
Absolutely. I think Shazad, that's a great point there. And thanks, Nicholas and Saad, for getting us started. And you guys hit on the application aspect, and Saad, your top point was application/infrastructure. And I'm gonna make a mouthful of statement here and then expand what I mean, right? So what I feel is coming is that the per iota density of complexity in the cloud is just gonna rise exponentially, like multi-fold increase in complexity. Many enterprise, I feel, are not seeing this coming. They're happy with, it's good enough for me today. It's good enough for me now, right? And they're not really prepared. And I feel that if you're not prepared, if you're not seeing that complexity coming your way at 300 miles per hour, you will be, you will be challenged. So what I feel is that the rise in complexity, the multifold rise in complexity, will result in different kinds of operational models that would be needed. And these models are not going to be something that you can just set once and forget. These need to be evolved, evaluated repeatedly. Like, it's not going to be a stagnant thing. And if your architecture is not future proof, it's not something that takes this rise in complexity, rise in operational overhead into account, you will be hurt. So what I think is that any enterprise that goes with an architecture that not only just sees this thing coming, but it absorbs it and embraces the complexity, those enterprises will be successful. Because the thing is, the complexity is not necessarily a bad thing. The complexity gives you, a lot of different features and capabilities, and I'll try to give some examples to expand on that. But so don't try to walk away or be scared of the complexity. Invest in an architecture that allows you to benefit from that complexity, right? So if you think about, going back to what I initially said, that the per iota density of complexity is going to increase. If you look at how our data centers were built, right? The data center build, or the data centers also were complex, but they didn't become complex overnight, not even in quarters or a year. They became complex over decades, right? So that was the pace at which things were moving. But when you're in the cloud, if you think about the pace, the velocity at which the CSPs are throwing services at you, right? And each CSP is throwing service at you. Nicholas, you mentioned Kubernetes. So if I look at Kubernetes in AWS, I have ECS, I have EKS, I have Fargate, and I have some other thing that just got announced, and then this is so that can go on-prem and stuff, right? So if as an application team, my focus is just application and its feature and what it offers me today, by the time I'm done with deploying or building the application on that platform, my reasoning, my rationale to go with that platform is likely obsolete already, because the CSP has come out with 10 different features or things that just negates the reasons that you went with that in the first place. Now, if you look at an enterprise, no enterprise has everybody using the same thing. So you may see in an enterprise, taking that same example, a team going with ECS, a team going with EKS, a team going with Fargate. Then you don't have just one application, you have multiple applications, you have different line of businesses doing different things. Now you have multi-cloud, then you have some people using GKE, some people using Anthos, some people using AKS. If you just think about the complexity that is raising, everybody, when in their own small lens, they feel that, oh, ECS is so easy, AKS is so easy, GKE is so easy, or whatever. But when you kind of bubble that up at an enterprise level and you see the entire landscape, you see that the complexity is raising, right? And I'm just talking about one piece of it. Now think about step further back, and application teams are always about the latest, the greatest, the best. But the operations team that need to support it, now they have 10 different flavors of Kubernetes. The application, the ops teams are not even ready to support Kubernetes in its native form, and you're not throwing them at them like 10 different versions of container platforms, right? And then the even as Nicholas, you mentioned earlier, that each container platform, Kubernetes platform, has a siloed version of networking and security running within. So that's just one example. I'll give you another example because that relates to what you were saying earlier around serverless and private link as an example. So I talk to people in this, they feel that, private link is great, which actually as a technology, I really love it. It is indeed, really awesome. But now we are talking about enterprise, right? So imagine Azure provides you like what 80 something or 50 something private link services. AWS provides you 100 plus private link services. Now, on top of that, you can have your own private link services. You may have software vendors, third-party vendors providing you these services, right? So on a typical level, let's say you have 50 VPCs, and each VPC has even just 10 private link services, because on an average we see 50 to 100 different instances running in a VPC. So what that means is that per VPC you have like 10, 15 different private link services being consumed. Now, each of these private link services have to be multi-AZ as well. So you have to worry about that piece. You have to worry about provisioning. You have to worry about networking for those. And then you step back and you look at, oh, it's just one VPC has, let's say, 5 to 10 private links, cross 2 or 3 per AZ. Then you have, 50 VPCs. So I have now 500 private links. Now I step further back and I look at multi-cloud, and again, merger, acquisitions, line of businesses, different things driving multi-cloud. Then you have thousands of these private links, right? Which on their own small iota were simple. What's the big deal? But when you look at the enterprise scale, that's massive, right? So that's why where my prediction goes is that the density of all these services are just gonna keep cramming onto each other, making it very complex and making the support very complex. And the last thing I would say in that, and again, the example is that these services are not independent of each other. They are interlinked. They have interdependencies. So a unfortunate but good example of this thing is the recent AWS outage. The outage didn't happen across the board. It happened only in one service, Kinesis. But it impacted CloudWatch, Cognito, Autoscaling, Lambda, EventBridge, ECS, EKS, Service Test. All of these things got impacted. Why? Because they're all interconnected, right? So that's where what I mean by the rise of complexity. It's just everything that has so much interdependency. And then each of these services are releasing new features so fast, the velocity is just off the roof, right? So as an enterprise, if you do not have an architecture that embraces this complexity, right, that is ready for this complexity, that is ready to embrace it, not fight it, embrace it, and lets you, take advantage of this complexity, gives you visibility, gives you connectivity, gives you security, all the things that enterprises need, then you can let the applications and teams, use more and more of these services. Of course, some complexities have to be handled at the application layer. But if your core network infrastructure is designed with the right, knobs and eyes and ears, then your applications team will be happy, your operations team will be happy, and the complexity will catalyze in a positive way your enterprise adoption, not in a negative way. Because if you don't have that visibility and control and operational readiness, you'll be down on your knees. You won't be able to move because the complexity would just slow everything and everyone down. So that's just, like a little bit of what I see coming is people need to be prepared. Don't be just satisfied with it's good for me now. You need to be ready because things are moving at an immense pace.
So that's interesting, Ahmad. So what about the operational challenges related to security and compliance then?
Yeah, I can take that one. So basically, you guys talked about the complexity, the application space is changing, landscape is changing. The job of the security guys is becoming very difficult now because of all this complexity and multi-cloud that is happening out there. And even if you look at 2020, you guys notice there were so many breaches that happened. The FireEye breach, or the SolarWind. We also saw a major tech company conferencing system went down due to some bad actors. So people are trying to attack your infrastructure from left and right, from within or from outside, right? So I don't think this is going to go down. This is going to increase. That's how I see it, and this is unfortunate, but we cannot do anything about it. Now, even if you look at the US government, they are putting a lot of investment into this area to provide the security for the security infrastructure and for the cybersecurity infrastructure as well, right? In 2020, we saw about 2 billion was given to CISA, which is Cybersecurity and Infrastructure Security Agency. And that's just one example. And if you look at the overall spending, it's a lot, right? So this is going to increase. And the way I see it, this goes hand in hand with visibility and monitoring as well, because if you can't see something, how would you protect it, right? So you have to identify the traffic flows, the traffic patterns, where they're coming from, and then you can provide the security around it, right? So my prediction is that the spending will definitely will grow. And with that, what I'm also seeing is that when people adopted cloud early on, they went with kind of a distributed security architecture where they started deploying the firewalls into VPCs, and then it actually grew, right? So now people are converging. People are saying, no, this is a very difficult to manage, operate, and to govern, basically. So what I need a centralized location where I can bring all my traffic flows and provide security and have proper governance and audit controls. And this is another prediction I'm making, that people will invest heavily in this type of architecture. It's not going to be distributed like it was before. It's going to be centralized, so it can be better protected. And even within centralized model, you can still take advantage of distributed nature of the flows. So you can have the centralized model for the east-west traffic flows versus the traffic flows that are going towards your internet, right? So you can still do that. So this is what I see will grow a lot. And another thing I'm noticing is happening due to COVID-19, right? We saw a massive adoption in the technologies that are focused on working from home, right? So more and more people are working from home. The employees, the developers, they are connecting into your infrastructure, into your cloud infrastructure, and they are putting the burden there. Now, when you're connecting there, what do you need? You need to provide proper security and governance control there, right? So that can only be handled by a policy-based architecture. And this is what I see is going to happen. People will be more concerned about it. Like, if my employee, developer, or partner is connecting, how can I make sure that he or she is still within the boundary that I define for him or her, right? So this is going to happen. People will invest a lot into this. And as an IT person or a person in charge of your NetSec or network security solutions, you need to make sure you're providing proper segmentation when they're coming in. You need to make sure you're investing into advanced technologies like SAML-based user VPN type technologies, where you can club it with the two-factor authentication or multi-factor authentication. The password itself is becoming a problem for a lot of enterprises, and they are moving towards a passwordless type solution. So this is where you guys need to invest when it comes to providing the enhanced security posture. The last piece that I would mention here is about the egress traffic. Nicholas mentioned about serverless and Kubernetes and the need to connect to the outside world. It could be a connectivity to API gateway. It could be connectivity to a SaaS service, right? Or connect to outside world like GitHub or Ubuntu and whatnot to get the patches or connect to your CI/CD system. So that need will not go away, right? So egress traffic is increasing. Now, if you rely on the legacy way of handling this traffic, that's not going to work. You need to provide or invest into egress-based solution, egress FQDN-based solutions, or something more advanced of that nature. So that's what I see, and that's what I predict.
Great. Yeah, I agree with you, Saad. I think we're going to see a lot in terms of security, compliance, all of that moving into the cloud needs to be rethought a little bit, needs to bring it up to the way that it needs to go.
Naman, you want to wrap it up for us? See how you're thinking? Oh, you're muted.
So, so in my opinion, I think the cloud awareness and the cloud maturity will drive certain behaviors. And one of the things that we will see is the multi-cloud, and especially the multi-cloud networking, will evolve from a theory and a recommendation to more of a well understood best practice, right? And this is something we will see in 2021. In 2020, what we saw is well established customers who thought that they would never go into a second cloud. We saw them go into multi-cloud in just a matter of days, right? Because this is a decision which is a business decision. We always say that it's not a technology decision, it's not an architecture decision, it's something that will happen to your business and you will have to react, right? So people, like merger and acquisition is one example where you have the primary company maybe in AWS and they acquire something in GCP, and now all of a sudden you need to manage that as a multi-cloud network architecture. What you will also see is most of these CSPs are getting better, right? Every day they are introducing new services, they're making the infrastructure better, and the relationships are building, right, between the CXO level. And obviously, a lot of customers have workloads which are not dependent on a single CSP, right? So for those type of workloads, if you have a better infrastructure at low cost with better performance available, then me as an enterprise, why not, right? So you will start to see that process of osmosis happening where people will start to adopt different clouds. They will start feeling comfortable as new relationships are building, and you will see that more and more, and it will become a norm. Now, I think that enterprises will still have a primary cloud and they will have a second or third cloud, but you will see that common. And one of the things that will also happen is, as I always say, that it's enterprises are looking for faster, cheaper, better, and closer. So the closer aspect of it is very important. Where, let's say, if I'm a global enterprises and I need to have applications running in, for example, China, I probably need to go and work with Alibaba Cloud as well, right? So the key part is that you need to do all of this in an architectural way where it doesn't add to operational complexity. You need to be able to abstract that and find solutions that will make it easier for you to run and use the best of breed of these services and infrastructure across multiple clouds. And more and more CSPs, even the most conservative ones, are now actually advertising multi-cloud. They are coming out with products that works across multiple clouds. Look at Anthos, look at Azure offerings that you have. Even in AWS, they were started to even encourage multi-cloud in many aspects. So that's one thing that will happen, where it will become established best practice for enterprises to have a multi-cloud network architecture. The second thing that I predict is the you it's 2021 is the year of partners, the system integrators, the channel partners, and you will see a lot of born in the cloud partners thrive in this public cloud space, right? So right now we are 4%, 5% of customers on the public cloud. There's so much skills that are lacking in traditional partners because they have been selling hardware, they have been building their capability in on-prem world for decades. But when now things move into the public cloud, nobody is asking you to install hardware or software. Nobody is asking you to design the things you have been designing in on-prem world. So you will see those smaller partners who are born in the cloud partners who are helping customers with lift and shift, refactoring their applications, rewriting their applications. They will start to get better and better because they are the ones who have the relationships built out. They are the trusted advisors for those customers. You will see them grow in their business in all aspects, and you will see new WWTs and new presidios and new dimension datas formed. Just like you will have cloud horsemen who will be the vendors of the new world, you will see partners also thrive in that space. Uh, that's my second prediction, and it's a year for partners to capitalize. The old traditional partners, they are seeing their revenue shrink, and they will also move, but their movement will be slow, right? Because they're tied to their current revenue. They don't understand the marketplace model that well. It's that slowness that will take them some time, but you might see them acquiring some of the newer companies or newborn in the cloud companies to be relevant in the cloud. The third sort of a sub prediction that I have is enterprise IT is again related to the matureness. Is enterprise IT, the partners, the customers, they're all becoming relevant and more informed in the cloud. They are doing certifications. People are moving from the on-prem legacy vendors to CSPs. We can see that happening all over the LinkedIn. You may have seen that. So what we'll see is initially when people were moving in, they were moving in for agility, right? And there was not a lot of maturity in terms of how do you manage that. So people will take a step back and say, okay, am I architecting this correctly? Right? Is it just stitching that I'm doing, or is it about properly making an architecture that will allow my applications to run smoothly, right? And one of the things that I think will be a highlight that Shazad also mentioned is security, compliance, and governance will be the key, where all of these maturity will translate into doing it right. And architecture will be in the forefront, security, compliance, governance will be at the forefront. And the second, as Rod, you mentioned earlier, operational efficiency and operational excellence will be another factor that will be very critical in 2021 for enterprises, and will drive how things get architected in the cloud. So that's sort of a three sub predictions based on the cloud maturity and awareness that will come in 2021 for.
Fantastic. Well, it's been very interesting, guys. I want to thank you all for coming on. I mean, these are our top solution engineering guys. They spend time with customers almost every day. So they're seeing this stuff happening in real time. And so, this is the kind of thing that leveraging Aviatrix, you can get that kind of experience if you want to engage with this team. So just to summarize, I think we heard, application-driven, application environments, moving to Kubernetes, containers, serverless, and needing the network infrastructure in the cloud to support those things. Those applications being driven out to the edge because the application needs to be closer to the users. Maybe it's we have latency issues, we have bandwidth issues, and 5G is going to contribute to that. But the architecture that allows you to pull all that together at the edge is very important. Compliance and security, we heard that many times. And then I think as an overall umbrella, there's going to be an increase in complexity from all of this, and that's going to require real enterprise class operations that it's going to allow you to do all of these things. So I think in the end, great session, guys. Everybody that joined, thank you very much, and we'll look forward to a great 2021.
Awesome.
Thanks, guys. Take care.
Thank you.
All right, there we are. Vicky, can you pull up the poll? Great. We always ask you guys to fill out the poll. It gives us a lot of good feedback. So please fill out the poll while we look for any of the Q&A. I didn't see any Q&A come across, so maybe we just hit the points well. Or if you want to get in touch with any of these experts, use info@aviatrix.com and reach out to us and let us know that you actually want to go in depth, you want to get a demo, you want to have an architectural discussion, any of those things we can help you with. And just a reminder for any of you who are not ACEs at this time, we're getting a lot of people. I think we're at or close to 10,000 certified ACEs now. So check out aviatrix.com/ACE and look at our self-paced or instructor-led classes that are available. I encourage you guys to do that. Let's just go to the next slide real quick, Ahmad. Yeah, so just coming up, we've got a bunch of more Tech Talk Tuesdays. So come join us on and see these. The first one is actually a webinar with AWS on January 21st. We're going to review what happened at reInvent and look, we've actually got a couple of speakers from AWS. We're going to focus on outposts and wavelengths and serverless and the new gateway load balancer, how we're supporting that. So some really good AWS focused things on January 21st. On January 26th, we're going to do a little bit of a deep dive into all of the multi-cloud network security and compliance capabilities of the Aviatrix platform. On February 2nd, we're actually, we've just had a guy join from Citibank, who's now our new field CTO. He's going to give some really good perspectives. He's been working at Citibank for 20 years and was the former director of network engineering globally. So some really good perspective from an enterprise customer who's now actually working with Aviatrix. And then on February 10th, we're going to look at some of the top multi-cloud networking requirements that folks have in a Google Cloud platform, as we're seeing that grow exponentially. Actually, we're seeing a lot of customers who are going in as their second cloud or their third cloud into Google Cloud Platform. So with that, I'll say goodbye for today, and we'll see you on another Tech Talk Tuesday.